Case 2 is repeated linear factors. For example 7, we need to express the following in partial fractions. The first step is to determine whether this is an improper or proper partial fraction. Here we can see that the highest power in denominator is less than the highest power in numerator. Therefore, this is an improper partial fraction and hence we need to do the long division. And hence we'll get this equation. Make sure you factorize denominator completely. So now, only look at this equation. There's no need for you to look at the previous equation anymore. And this is the partial fractions that we need to do in step 2. So now we need to determine what kind of factors do we have in the denominator. For repeated linear factors, you should have something that looks like ax plus b to the power of n. In this case, we have x plus 1 square, so we know that this is linear. However, it is repeated twice because it is squared. So how do we write the fractions on the right hand side? If it is squared, this means that you're gonna have two summation of fractions. The first one is x plus 1 to the power of 1, which is just x plus 1. And then the other one is x plus 1 to the power of 2. So don't forget that this is a repeated linear factors. Since the power is 2, that's why you need to repeat this x plus 1 twice. Now, what if you have something that looks like this? You can see that this is also linear factors, but this is repeated because it has to the power of 3. Since the power is 3, therefore it is repeated 3 times. The first one is x plus 1 to the power of 1, so you can ignore to the power of 1. And then we have x plus 1 to the power of 2. And then finally we have x plus 1 to the power of 3. Let's go back to our original question. So what do we put in these spaces here? As long as it is a linear, we always put constant in the denominator. So we're going to have constant A and constant B. So this is the equation that we have. As per usual, we need to eliminate the denominator. So multiply everything with x plus 1 squared. And we will get this equation. So now we need to do substitution. Note that we have two unknowns. Therefore, we need two values of x. And you know that we should use all values of x that comes from denominator. So when you let it equal to 0, the first value of x is negative 1. So we need two values of x. However, from the denominator, there's only one value of x. So what about the other value of x? You can pick any values of x that is easy for you to do substitution. So try to pick like x0 plus minus 1 plus minus 2, etc. Since we already have x equal to negative 1, I'm going to choose x equal to 0 as the other value of x. So now let's substitute both values into our equation. And we will get b is negative 13. Negative 8 is equal to a plus b, but don't forget b is negative 13. And hence, a is 5. Now substitute both values of b and a back into the partial fractions. A is 5 and b is negative 13. But don't forget to simplify on the right hand side. Positive negative 13 is just negative 13. The last step is to rewrite step 1. And this is from step 1. And note that this fraction is actually these partial fractions. And hence, this is the answer for part A.